Okay, so I'm picking back up at 33, and I'm sorry in advance. So an aqueous potassium nitrate solution is made using 72.5 grams of potassium nitrate diluted to a total solution volume of 2 liters. Calculate molarity, molality, and mass percent of the solution. Assume a density of 1.0 grams per milliliter for the solution. So for this problem in particular, I'm sorry, I'm sorry, because I should have ordered it molarity, mass percent, then molality, and that would have made it easier, but I didn't, and I'm sorry. So the problem will either give you the molecular weight or have you find it really quick. Probably for time's sake, it'll give it to you. So it's 101.1 grams per mole. So to find molarity, which is mole solution, or mole solute over liter solution. So it's going to be 72.5 divided by 101.1 over the liter solution, which it says is 2. So when you divide that out, you should get 0.3585 molarity. So the next one is mass percent, which I'm going to hop around because I think it makes more sense. So it tells me, it gives me the volume of the solution and the density of the solution. So it will give me the mass of the solution, right? And it already gives me the mass of the solute, which is 72.5. So you're going to solve for mass first, so 1.05 gram per milliliter. I need to convert liters to milliliters, so that's going to be 2,000 milliliters over, so this is going to give me gram solution, or mass solution. So it's going to give me a mass of solution of 2,100 grams. So that's the total mass. So if I want the mass percent, now I just do 72.5 over 2,100. Well, that's going to give me a mass fraction times 100. So when I do that, you should get 3.45%. So now that you have both of these masses, it's a lot easier to go back and find molality. But remember, for molality, it's going to be moles of the solute over kilograms of solvent. So that's why it's more important for me to find that mass of the solute, or the mass of the solution first, and then do that. So to find the kilogram solvent, I'm going to take this mass right here, which is the total, and minus 72.5 grams from it. Minus 72.5 grams. And so when you do that, you should be left with 2,027.5 grams of H2O, which is our solvent. Because remember, the mass of solution is just the mass of the solute plus the mass of the solvent. So it's just going to be solute plus solvent. So when I convert that to kilograms, it's going to be 2.0275 kilograms. So I'm going to use that same molar value from part A, which I didn't write out, but it's akin to 0.717. So you put 0.717 over 2.027 to get the molality, which is 0.3536. So really similar to molarity in this case. So that's okay. So I move on. So what volume in milliliters of a soft drink is 10.5% sucrose by sorry. Reading isn't my strong suit today. It's been a really long day, but that's a-okay. So if I move on here, it asks about the vapor pressure. So what I need to do is find the mole fraction. So the molar mass of sucrose is 342.2 grams per mole. Like I said, it should give it to you, or would have you do it. I would bet on it giving to you, but if not, it's not that difficult to find. So what I need to do is find the amount of I need to find the mole fraction. So what I need to do first is I need to convert this in 2 grams, which is nice because it's just 1 gram per milliliter. So 300 milliliters of water is also equal to 300 grams of water. So I need to convert the sucrose to moles, which is going to be 99.5 grams over 1 mole, 342.2. So when you do that, you should be left with hold on, I'm having difficulties reading my notes. 0.2907. So when I find the moles of water, which is just 1 mole over 18.02, it's going to be equal to 16.648 moles. So what I need to do now is find my mole fraction, which when you do that out, it's just going to be 16.648 over 16.648 plus 0.2907. And that's my mole fraction times that partial, well, I guess the equation you use is that pressure equals X, so that's the mole fraction times the pressure of the pure solvent. So I didn't write that out to begin with. But you multiply that by that pressure it gives you, which is, this is the pure solvent, so it's going to be times 23.8. So when you divide and multiply those terms, you should get 23.4 torr. So that's B. Okay, so 36 is something I don't think I touched on in my OPAL session, but a positive deviation from, so Raoult's law is basically just a prediction of pressure, right, and intermolecular forces. So remember, what we've had previously is that you should have a formal line like this if it follows Raoult's law, if it abides by this. But if I have a positive deviation, meaning this is basically this is vapor pressure. So I have a positive deviation, meaning I have a higher vapor pressure. Well, that's going to tell me that the solute-solvent interactions are weaker than predicted. Because if they're weaker than predicted, that means that it can break through easier, right? If I had a negative deviation from Raoult's law, meaning that there's less vapor above the solution, that means that those particles are held tighter, meaning that the solvent-solute interactions are stronger than predicted. So I know that it has to be A. And if it's an ideal solution, it will follow Raoult's law. So 37, osmotic pressure, so it's going to be pi equals MRT, so it's osmotic pressure equals molarity times the gas constant times temperature. So when you do this out, this one's a little bit tricky. So it gives me my pressure, it gives me temperature, and it wants me to find molar mass. All right, so to start out, I would just solve for molarity and go from there. So I would write my 2.88 millimeters mercury equals M, and then R, which is 0.800826, times T, which is going to be, we're going to put it in kelvins because that's what this dictates. So it's going to be 25 plus 273, which is 298. So you should get a molarity of 1.51 times 10 to the negative 6, right? So what I want to do from there is convert molarity to moles, which is going to be moles per liter. So I'm going to put 1.51 times 10 to the negative 6 equals my volume, which it tells me is 50 milliliters, so that 0.050 liters over moles. So when I multiply that out, I get 7.565 moles. Well, not times 10 to the negative 6 moles. Sorry about that. So I'm just going to move over here for a second. So when I do that, I know that moles is just equal to mass over molar mass, right? That's how I find moles, is dividing whatever mass I have by the molar mass. We did it up here. So that's just a way to synthesize it. So 7.565 times 10 to the negative 6 moles equals molar mass, times the mass that I have, which is 22.7 milligrams. So when I convert 22.7 milligrams to grams, it is 0.0227 grams. So I multiply over. So I divide this top number by this number to get my molar mass. And when I do that, I get a molar mass of, when I plugged it in, I got 3,000.66, or it's closest enough to 2.93 times 10 to the 3 grams per mole. I would be surprised if you had something like this. Just know, like, this is as far as it can go. I would use these as a benchmark of how, like, well you know the material.